Today we're at Materials Solutions in Worcestershire and I'm here with Rob. Rob, what a brilliant facility. I can't wait to go inside and find out more. This is one of the largest metal additive manufacturing facilities in England, I believe, and we're going to be also looking at some of the GOM automated solutions.
Yep, perfect. So yeah, welcome. So today we're here to learn a little bit about metal additive manufacturing and see one of our long-term customers, Materials Solutions. They've been a customer of ours for more than 10 years. And yeah, I'm really excited to show you around to learn more about the process and about how they're using GOM automated metrology. Matthew, can you tell us a little bit more about Materials Solutions and what we're going to see today, please?
So yeah, Materials Solutions is one of the largest additive manufacturing sites in the UK. Started in 2006. We received some Siemens investment in 2015 to become a public company, and we've grown massively through that transition. Now owned by Siemens Energy, we produce components for all types of industries, from power generation, automotive, motorsport, space and aerospace. We work with a range of materials as well. We have a large selection of machines at our Worcester site, and I will be taking you through the printing process today, taking you through the finishing processes, the interim processes, and heading around to the inspection department as well, so we can see the GOM solutions in action.
Perfect, that sounds great. Should we go and take a look?
Let's do that.
Additive manufacturing, metal additive manufacturing is certainly changing the landscape of engineering as we knew it. So can you talk us through the technology that you're using here today and the processes to manufacture some of the parts?
Sure. So this is one of our EOS M404 machines. So that's a multi-laser metal SLM machine. So the process starts with metal powder, in this case loaded with Inconel 625, so that's a high temperature nickel alloy, printing components for Siemens Energy's gas turbine business. So the AM process is a layer by layer process. So in this case we're printing parts which are about 200 millimeters tall, but in 40 to 80 micron thick layers. So it's a very step-by-step process, building up the component over a number of hours or even days in some cases. Each layer is fully melted into the previous layer, so the resulting component is as solid as any other casting or forging process would make it.
Now these components, Inconel you mentioned, very exotic materials for critical parts. Can you tell us about the part and the parts applications?
Yeah, sure. So this is one of the parts that's printing on this machine right now. This is a fuel swirler for a Siemens industrial gas turbine. We're producing 3,500 of these this year in batches of 20 parts on the EOS M404s. Next year we're looking to ramp up to approximately 5,000 parts in this family, and the production numbers are only going to increase from there.
I mean, that is astonishing really. You wouldn't necessarily associate high volume parts, especially critical parts, with metal additive manufacturing.
No, well that's the thing. So we're what our business here is to productionize the additive manufacturing process. So whereas previously it had been mostly R&D focused or small one-offs, we're building the process into something that can be used for high volume parts in a range of industries. Gas turbine industry is a good place to start. It gives you there's a lot of components that have parallels with other industries as well, so it enables us to build data and prove out processes and develop our expertise for other businesses as well as our own.
Matthew, behind you I can see a screen and it's showing that you can print multiple components at one time. Can you explain the printer's capacity, but also how long does a part like that take to print?
Sure. Well, the EOS M400 has a 400 by 400 by 400 millimeter build volume, so that limits in some way the size and the quantity of components that we can print at one time. But in order to achieve our production scales, our production volumes, we have to get creative with how the parts are placed within the build chamber. So you can see on the screen here we have 20 of these components printing at the same time across 4 separate lasers. So we have some parts being printed with one laser and then another, and another. and we can see that we are roughly halfway through the build at the moment, and that's a 3-day build to produce 20 of these parts. So the machine prints 24/7. It'll print throughout the night. Doesn't need any intervention except when loading and unloading the build. So you can cycle through the build process from the very start here. You can see the first layer when it prints the supports. You can see the ring of the part starting to print up from the base. Scrolling through layer by layer, 80 microns up to here, 40 microns through to the top of the components. Once we get past the aerofoils, we skip back to 80 microns to speed up the process and get the build as efficient and as quick as possible in order to achieve those production numbers.
Matthew, fascinating, and I'm assuming that there's very little wasted material.
Quite right. So the machine itself is loaded with 190 kilos of powder. However, the only powder that's actually used is the powder that's used to build the component. There is also support structure that's built, which is wasted, but that goes through a recycling process later on and can eventually come back through as metal powder.
And what happens when the parts have been fully printed? What happens when they get taken away from the machine?
So the parts, when the build is finished, will be coated in the powder material. So that has to be cleaned away. The powder is vacuumed off to be recycled. So we maintain a recycle count on the powder itself. And then the parts will go through a depowdering process to remove any residue of powder contamination on the components, partly for foreign object debris reasons, partly for health and safety reasons. Obviously with a nickel alloy, there are various considerations.
And how do you remove the support structures?
So the support removal process can in some cases be as complicated and time consuming as the part build itself. However, for our productionized components, what we aim for is as little as possible. So for these parts, we use a wire DM or a precision bandsaw to remove the parts from the build substrate, and then the supports themselves are simply snapped off, and then that gives you the finished component effectively. There is very little processing for these productionized components. More complex parts may require additional hand finishing work or machining post-processing.
So many processes still required for the manufacturing of these complex parts. And whilst I'm on the subject of complexity, the complexity of these components are evolving all the time and becoming more complex all the time. So how do you inspect them?
So we use extensively Atos Scanbox 3D scanners in order to verify the geometric conformance of these components. During pre-production and production qualification, the 3D scans are invaluable to assess the full surface of the components against original simulations that engineers have performed pre and post heat treatment in some cases, and moving through to production to get a cohesive picture of the whole of the components and how they're likely to fit together with other parts in assemblies later down the line.
We've now relocated to the metrology department, and you're actually located within the Atos Scanbox. Now, Matthew, you told me that you've chosen GOM to check the swirlers, but before we find out the reasons why, Rob, can you give us an overview into your technology, please, and the relationship?
Yeah, perfect. So the relationship with Material Solutions started more than 10 years ago. So they first invested in the Atos Compact Scan, which is still used here today. When they moved to this purpose-built facility, the investment was made into the fully automated Atos Scanbox, which we're in now. And then more recently, they've also purchased the GOM Scan Cobot. This allows for greater capacity and throughput of measurements, but also some redundancy in this automated system, and allows for easy automation of one-off or very small batch numbers. Just taking a step back, I guess, as well. So Atos is our family name for our 3D scanners. So this is the Atos capsule, and it can be used in a manual form as the compact scan is, but it can also be part of this off-the-shelf automated solution, which is the Atos Scanbox. So at the moment we're inside the Atos Scanbox 5108, which is one of our smaller scan boxes. There's a couple a little bit smaller, and then the increasing size and capacity up to the largest one where you could drive a large van into. The benefits of the Scanbox is that it's an off-the-shelf proven solution that can be globally rolled out, and it's aimed ideally at production inspection.
So, Matthew, why did you specifically choose GOM?
So, as Rob mentioned, we started with our first GOM system over 10 years ago, primarily to gain a better understanding of the surfaces of our components. The benefit being with GOM compared to conventional measurement systems is that you get a full field measurement. So you see anything that you can capture in line of sight, you can visualize and compare against the CAD. You can perform geometric inspections, GD&T inspection, and the software really facilitates that nicely. It's very intuitive, easy to use. The 5108 Scanbox that we're in at the moment is perfect for our parts. It's just the right size for the range of products that we can produce. And as you can see here, we're able to inspect multiple parts at the same time in a multi-part fixture and automate that as much as possible. So we have a single simple carriage loading system with a relatively low user input in order to set this running for the full inspection of these components. Then that frees up the operator to run either our other systems, our Cobot, our manual GOM, or process data in the meantime.
Can you tell me about kiosk mode?
Sure. So kiosk mode is something that we've really benefited from lately. It's enabled us, again, reduce our operator input. It's enabled us to bring in non-metrology trained employees into operate the Scanbox overnight during late shifts, that sort of thing. And it really streamlines the process of setting up and running an inspection.
Rob, can you tell me a little bit more about kiosk mode, about the GOM Inspect software and how important this is to the complete solution?
Yeah, sure. So as Matthew said, the kiosk mode is a simplified mode which any level of operator can use. It allows for things such as even a barcode scanner to be automatically used to select the correct measurement template, again reducing the risk of errors. It also allows via the touchscreen interface to have data presented back to the end user as well.
So Matthew, is it really that easy to use and to program?
Yes, absolutely. So that is one of the things we really like about the GOM software. It's very intuitive. It's all graphical, and compared to conventional automated inspection methods, it's very quick to set up a program that will capture a good amount of data. There is still some complexity involved. So where we have the close spacing of the vanes, the narrow internal passages inside the components here, it does require the full utilization of the tools and functions within the software in order to get good surface coverage. But the inspection coverage that you do get is way in advance of what you'd see from other conventional methods. We're also excited to use the integrated Smart Teach tools with our Cobots for our lower volume stuff in the future.
So Matthew, I want to learn more about the GOM Scan Cobot. This is your latest acquisition. Why did you purchase this?
So that the main reason was to increase our production inspection throughput. But it has the other benefits of allowing us to move some of the scanning that's still done on the manual Atos Compact Scan over to a more automated system.
And from a technical perspective, Rob, this is a new product from GOM. Can you give us an overview about this product?
Yeah, so it still essentially is a Scanbox, so it's using the same VMR, virtual measuring room software. So it means that the programs that are developed on this 5108 can be easily transferred across to the GOM Scan Cobot in the same way that those programs can be transferred from system to system across the globe.
Now the GOM Scan Cobot is also portable, I believe.
Yeah. Yeah, so with it being portable, you can take it out of the metrology room and take it to the measurement task.
So effectively, Matthew, it's increased your capacity.
Mm-hmm. Yes, that's exactly right. So, and we're hoping to gain more use out of it and make better use of its, as I say, automation for the lower volume stuff as well.
Automated 3D metrology plays a big role at Materials Solutions. Now, how important is the software side in the GOM Inspect, Rob?
Yeah, obviously very important, and it's not just as GOM, it's not just the hardware we're delivering, but it's the complete solution as well with the software. From the start of the process for the auto teaching within the VMR software right the way through to the analysis and reporting software, which Matthew can show us some of the advantages now.
Sure. Yeah, so the software manages the whole process start to finish. So you can see here we have a part scanning at the moment. This is our swirler from earlier. And over on the right-hand screen, we have a completed scan. So this is as it comes off the fixture, the mesh data polygonized in the GOM software and processed, ready for inspection. From the we complete the entire of the geometric inspection within the GOM software for these components, and we're able to capture all of the critical surfaces that the customer requires. So we can display a surface comparison against the customer's CAD file. This shows us individual small areas of deviation that would otherwise be missed with conventional probing strategies. It also shows us a general idea of roughly the shape and size of the part. Going deeper than that, we have full geometric inspection. So diameters, linear dimensions, anything that the customer puts on the drawing we can inspect with GOM software. GD&T features, so these parts require tight run-out tolerances to internal datums, and GOM software lets us visualize exactly where the deviations may occur, and going back from that back into the process, we can feed this information to improve the next stage of manufacture, or the next set of parts being manufactured. So we may identify a slight drift in one batch. We can adjust how the machine is set and tweak it so the next one coming through is back on track. The range of capture that's possible with the GOM software is another big driver for its use compared to conventional inspection methods. So the internal fillets of this component, they're very complex shapes, so they're hard to reach, but with careful programming of the GOM system, we're able to capture the full circumference of these fillet areas, which are critical to the airflow and performance of the component.
I think that's a really important point. So if you just drag the mesh back out and just show the coverage, I mean, when you look just visibly with your eyes at this part, it's being able to get all of that data to the levels of detail we do. Maybe if you turn on the mesh structure, it's amazing the millions of points that make up this and the depth that we can get within this part.
So that's another benefit of the GOM software, really. It's the resolution that you can capture. So you can see we've looked at the physical part, and now we can really zoom in and see the fine details. You can see where there may be slight manufacturing defects, very, very slight though, which would, there we go, a bit of, we would call that weld spatter. So that's likely to be around 0.1 or so millimeters of material on that surface. Would never be captured with a conventional method, but we can see that it's there. We can see whether we can adjust our methods to
This
reduce
looks
that.
to me a very powerful piece of software. Now, does this enable you to create a stable process?
Yes, 100%. So one of the challenges that we faced with these parts originally with the GOM inspection of these was the same challenge that we faced with conventional methods. It's access to the parts. However, through the iterations that we went through with the programming of these, we're able to capture good data all the way through these vein sections, which is not a simple measurement. We would we didn't really understand or expect that we'd capture such good data with the GOM system, but the triple scan that we gained with the Atos capsule is, I believe, part of the reason that we're able to get such good and complete data capture throughout this component and on leading edges, trailing edges, all over the vein surface. Good and repeatable, robust data.
And how important is the standardization of the processes in regards to not only manufacturing the parts here in the UK, but maybe in Berlin, for example?
Sure. So the programs that we produce here on our Atos Scanbox 5108 are 100% transferable to other Scanbox systems at our sister sites. So we have a 5120 in another Siemens site where we're producing similar components. We're able to scan with effectively the same programs and close to the same parameters and get very similar results.
Would you say, Matthew, or is it safe to say that this software is simplifying an operation that otherwise would have been quite complex.
100%, and the simplicity enables you really to push for even further efficiency or performance gains. So if the software was more complex to program, basically we wouldn't be able to spend as much time as we have optimizing it for repeatability and productionization.
Now you've used the GOM software and it's checking the parts, how does it give you the reports?
So the report templates that we use are customized for ourselves, so we have all the information in here, all the traceability information, all the part-specific information that we require in order to report per the customer's requirements and per any industrial regulatory requirements. We're able to, as I say, fully customize how we want the report to be displayed. We've got a table of all the results for quick reference, and we have individual pages showing the certain different dimensions, parameters of the part, as numerical values and as coloured representations.
A lot of information there.
Some of the other outputs available, I guess, as a PDF or CSV outputs?
Yeah, so we would, by default, our kiosk mode program will output a PDF and a CSV file. The CSV file we then use to import into other software for analysis later on, statistical analysis and storing in our database.
Perfect, and I guess the other thing to mention at this stage, so that this presentation mode is part of the free GOM Inspect software or GOM Suite software. So this allows us to take that data and anybody can download the software, so especially in the development phases, other engineers can have access to this data, they can do their own inspections completely for free on their own workstations. For example, Gio, even you could download this and give it a go.
Well, you've made it look simple. Thank you very much, Matthew. Thanks, Rob.
Thank you.
Thank you.
It's been a fantastic visit today, so thank you very much for your time and hospitality. I've certainly learnt a lot, and I'm sure the audience have learnt a lot too. Now, looking into the future, for me, and my opinion on this facility, it is a factory of the future, or as close as I've ever seen so far. What's your future strategy at Material Solutions, but also with the partnership with GOM?
So we've got a number of next steps for our factory here to increase the level of automation that from what we've already achieved. So you may see along the floor we have our AGV tracks to enable more efficient movement of components around the factory. We have semi-automated manual handling systems around the factory. We are developing a powder transit system, so we will be able to dose, recycle and maintain the powder automatically depending on the needs of the builds. Moving through to inspection, there are opportunities for batch processing and pick and place style systems that will merge with the automated part handling that we're developing in the factory itself.
So automation seems to be a big theme in regards to the future strategy here at Material Solutions, but what part will GOM play in this future strategy?
The Atos Scanbox as it is today is already perfectly prepared for automation, so from automation of the loading of the Scanbox right the way through to the automatic starting of procedures to make it a truly lights out movement. There's also in the future the opportunity to take this installation and have a global rollout of systems as you're already doing with some of your other sites already across the globe.
So can you explain to me in a little bit more detail how this will work from a global perspective?
Sure. So the goal of the Material Solutions factory is to be able to pick up what we do here, place it anywhere in the world. So the systems that we're developing and using here right now could just be moved to another site, and in fact we are running these same systems in our sister sites in America, Sweden, Berlin, to produce the same results that we do here, running cross-qualifications with GOM systems to prove out the repeatability of different processes and inspection methods throughout the world. And GOM systems are a key aspect of that, enabling us to really prove out the process, show its repeatability, and guarantee the performance of the final components.
Okay, thanks for joining us today. I hope you found it informative. Please join us now for a live Q&A.